One of the most important form of the infinite series is geometric series. Geometric series are series of the form a plus ar squared plus ar to the power n minus 1, which can be expressed as infinite sum from 1 to infinity a times r to the power n minus 1. Here a and r fixed real numbers, and a is not, of course, equal to 0. So we have two cases. If the absolute value of r is smaller than 1, then the geometric series converges to a over 1 minus r in this case. So this infinite sum is equal to a over 1 minus r. If absolute value of r is greater than 1, in this case the given infinite sum is divergent. So how to find the sum of geometric series? This question is very important. Let's say a is equal to 1. I want to solve this problem for a equals 1. So in this case we have, for the summation, 1 plus r squared plus r to the power cube, r cube plus, and finally r to the power n. Okay, let's call this as s. S is equal to. Let's multiply this equality by r. Okay, then we have r times s is equal to, so I multiply by r plus r squared plus r cube plus r to the power n plus 1. Okay, so if we subtract first equality from the second, then I can take the parentheses of s, so we have 1 minus r here. Then since we subtract, we can cancel these terms. We can cancel r squared, r cube, r to the power n, and finally we have 1 minus r to the power n plus 1, and s becomes 1 minus r to the power n plus 1 divided by 1 minus r here. Okay, this is s. So if we take the limit of right hand side, we will see that limit of rn plus 1, limit of rn plus 1 when n tends to infinity is equal to 0 when absolute value of r is smaller than 1. Just for example, if r is 1 over 2, okay, and the limit of 1 over 2 to the power n or n plus 1 becomes 0, since this term will go to 0 finally. So this term goes to 0 when, of course, absolute value of r is smaller than 1. In this case, this expression goes to 1 over 1 minus r if absolute value of r is smaller than 1. Okay, so we have a convergence case for a geometric series if the absolute value of r is smaller than 1. Very nice example. Otherwise, the given geometric series is divergent. We do not have a numerical value. Let's look at this example. 1 plus 1 over 2 plus 1 over 4 plus 1 over 8 plus, and so on. So it's better to write this infinite sum using the sigma notation. Using the sigma notation, we have n from 1 to infinity. In this case, a is 1, r is 1 over 2, okay, as you see. So we can check is it right or not. For n equals 1, we have 1 times 1 over 2 to the power 0, which is 1, so we get the first term. For n equals 2, 1 times 1 over 2 to the power 2 minus 1, which is 1 over 2, we get the second term. For n equals 3, 1 over 2 to the power 2, which is 1 over 4, we get the third term, and so on. So as you see, it is a geometric series form. In this case, a is 1, r is 1 over 2, and since absolute value of r, which is 1 over 2, is smaller than 1, this geometric series converges to 1 over 1 minus 1 over 2, which is 2. Let's look at the second example. Pi minus e plus e squared over pi minus e cubed over p squared, and so on. Again, we will express this infinite sum using the sigma notation from n to infinity. The parentheses of pi, we have minus e over pi to the power n minus 1. Okay, actually it's not so easy to write down the given infinite sum using the sigma notation. It's not always so easy. So I suggest you that you first write something and check is it right or not. So for n equals 1, for instance, let's check. We have pi times e to the power pi to the power 0, which is 1. So we have pi. It's good. For n equals 2, we have minus e over pi times pi, which is minus e. So we get the second term. For 3, if you check, we get the third term, and so on. So the next question, is it a geometric series or not? Yes, it is a geometric series, and in this case, a is pi, and r is minus e over pi. Okay? So absolute value of e over pi is smaller than 1. Why? See, since e is a number which is greater than 2, smaller than 3, 2 something, and pi is in between 3 and 4, so the division is smaller than 1. So according to geometric series rule, this infinite sum converges to pi over 1 minus e to the power minus e over pi, since r is minus e over pi, and if you simplify this expression, you will have pi squared divided by pi plus e. Since it is a geometric series, again we can use this formula, and since absolute value of r is smaller than 1, if you have the other case, if absolute value of r is greater than 1, then we would say the summation diverges. Let's look at the last example. 1 plus 2 to the power 1 over 2 plus 2 plus 2 to the power 3 over 2 plus, and so on. Again, it's very important to write this infinite sum using the sigma notation. Here we have from n equals 1 to infinity, square root 2 to the power n minus 1. As you see, we actually have square root for each number. Okay, for instance, for n is equal to 1, we have square root to the power 0, which is 1, so we get the first term. For n equals 2, we have square root to the power 2 minus 1, which is square root 2 to the power 1 over 2, which is the second term. For n equals 3, we get the third term, and so on. In this case, r is square root 2, and this is greater than 1. Even if a is 1, it does not matter. Since r is greater than 1, the given infinite sum does not converge. The given infinite sum diverges.